Okay, so the question is, sine x minus pi over 4, subtracting pi over 4 from x really feels like it's moving to the left, so why does it really transform it to the right? So one way that our anonymous students here have just said that this makes sense is, I think the phrase was, it has to be pi over 4 so that it makes sense, something like that. So let's think about it this way. I've drawn this bubble, and you can draw a bubble also. If I plug in an x value, you're going to calculate a new number by doing what it says in the bubble. And so the number that you end up with, that's the angle, right? So we could ask, what x value, let's think about it this way. What x value acts like the 0 angle for the original sine function? So it's like I'm going to plug in an x. I want to end up with 0. Because if I end up with 0, I know that the point I graph is going to be at the 0 angle point from my original sine function. So let's set it up. I want my angle to end up being 0. And it's a little bit silly to set up an equation here because you can just see it by looking. But we're setting up for a more complex scenario. So it's like, I want to know what input angle is going to go through this process and act like it's 0. So I could just add pi over 4 to both sides. And what that's telling me is that for my shifted graph, if I'm asking myself, what's the y value at pi over 4, if I plug in pi over 4, I'm going to end up with sine 0. So the point at pi over 4 is coming from the original graph at the point of 0. Let's do the same thing with pi over 2. So if I plug in pi over 2, tell your neighbors, where is the y value here coming from? Let me turn on the video again. So the phrase that makes sense to me, the number that's inside this bubble is an angle, right? So the angle in my new graph comes from x minus pi over 4. So the angle is coming from the place that's pi over 4 to the left. But that's why it's a shift to the right. Because if I'm always taking my points from the left in order to figure out where they actually get plotted, so here I'm taking each point. If I want to plot the point here, I'm taking it from pi over 4 to the left. If I want to plot a point here, I'm taking it from pi over 4 to the left. So if I'm always taking them from the left, that corresponds to shifting everything to the right. And so now you can kind of sketch the beginning of your curve. So this is the shifted curve. What I'd like you to do right now is try to do that same explanation. Think about, this is an angle, it's coming from somewhere, except now do it with sine 2x. See if you can say the story out loud in your group, see if you can make sense of it. If it doesn't make sense to you yet, try and work with it. Say it out loud different ways. Plug in different numbers to try and make more sense of it. You guys are doing good. Yes, we're recording again. Okay, so story number 1. So here's a scaled sine function. The angles here are coming from twice whatever x is. So if I want to know, what point am I going to plot at pi over 4? Well, let's look at twice pi over 4. So the y value at pi over 2 is what I'm actually using to plot at pi over 4. Okay, what if I want to plot the scaled value at pi over 2? Let's get the point that's at twice pi over 2, which is pi. And so this point is now going to come here. Well, maybe that's enough to go. Oh, let's do 0. So where's the point at 0? It's coming from twice 0, which is just 0. So if I'm going to connect these 3 points now you can sort of see that it's squished, because for each of my x values, I've doubled the angle to figure out what my y value should be for half the angle that I'm trying to plot. So it's like all the points that are doubled are now getting squished this direction because I'm looking at twice x to figure out where my points are coming from. Let's do it the other way also. So let's pretend that I want to know, and like if you're into writing stuff down, you could definitely write this down. So same idea. Instead of asking what x value acts like 0, let's ask what x value acts like pi. And what I mean by acts like pi is sort of halfway through the curve, right? So when I say acts like pi, what I mean is for this shifted, or for this scaled curve, what's the x value that is halfway through the new scaled curve? That's what it's like to act like pi. So let's set up our equation. I want the angle here to be pi, but I want to figure out what's the x value that I'll plug into the bubble here that will produce pi so that my x value will act as if it's pi. Great, so I'll just divide by 2. And like you see that that's happening. The point at pi over 2 is halfway through a full wave, and that's acting like the old value of pi, which was halfway through a full wave. So the two ways to think about it is what input will act like the original value for your curve, or think about where your angles are coming from, and that's what explains why it's reversed.